Thank you. So, okay. I'm a senior developer at Booking.com, and we work on a lot of stuff. This is a project that we've been playing with, and I'm presenting it. It is a tentative presentation, as in this is not the full-blown, we're done, it's good, everyone start using it. I want to share the background to this more than the application itself, but I will also share how it works because it relates to all the background to it. And we call it Pakket. Pakket is Dutch for package. And we figured package itself is probably a term that's both ambiguous and widely used, so we'll just use Dutch because it's not that widely used. Some of it is vapor in the sense that while the application is actually written, there are quite a few things that are not done on it yet. There are a few things that we know we want to have, but it's not there yet either. So do consider some things incomplete yet or incomplete. And if you have questions on which features that you see are available, just feel free to ask, and I'll try to leave room at the end. As well as pretty much everything that I will show exists and works and runs. But there are a few things that I don't show that just are not there yet. So there is partial vaporware concepts in Pakket itself and what it should provide in the end. So the title for this, the description that we have for the project as an unopinionated meta packaging system is not that clear until you understand what packaging is and why is it meta and what do you mean by unopinionated. So I want to start talking about packaging. It's the majority of this talk. Packaging is a problem that has been solved but still needs to be solved. What I mean is that packaging has a lot of perspectives to it, all of which are pretty much solved, but not together. So you can have some perspectives that were solved, and you could have other perspectives that were solved, but you can't have them together. And no one has actually really fully solved this problem. And that's what we're trying to do, because we like a challenge. Packaging has two different sets of users. The first one is desktop users, which is basically all of us at some point. We have a laptop or we have a computer, either at home or at work, and we want to have stuff on it. We want to use things. We are users of packaging in the sense that we need packaged applications and libraries, and we need to install those packages, and that makes us users of it. But we only want to install them. We don't want to build, we don't want to package ourselves. Another type of user is a company. A company is basically some of us at some point. And in a company, you have two types of users. The first one is the systems administrators. The sysadmins are the ones who create the packages. If you have a company, let's take Red Hat, and you want to maintain a set of servers. Well, of course, you're going to use Red Hat Linux, but maybe you want to patch for a few things that are not available publicly, which you're allowed to do. But then you have to maintain your own patches. You have to maintain your own packages. Red Hat are pretty good at this. If you are a different company, let's say Booking, we're probably not as skilled at this as Red Hat. But we do have our own packages for everything because we want to maintain our own patches, specific versions, editions. Some of them will go upstream, some of them won't. So that means the system administrator has to build everything. And then you have the end users, which are basically us again, but under the company. We need to install it. This also means servers. Servers need to install said packages. So you have the side that manufactures and creates, and then you have the side that uses. Sometimes our Linux distribution will be the one that manufactures, and we just run apt install or yum install. And sometimes we will be a company employee or a server for the company that needs to have those packages installed. Now, there are a lot of requirements, and I'm going to go over the big ones that I think of. The first requirement that we have for a package is speed. And this is often looked in situations where we have end users without a company. So when I'm on my laptop, it's okay if it takes another minute for a module to install. But if you're a company, this is not okay. If we want to deploy something, we have some server roles at the company that have over 1,000 servers. When we deploy software over 10 times a day to those over 1,000 servers for a single server role, we want it to be fast. In order to be fast, it means it has to be built ahead of time and then could just be installed directly. We don't want to run all the build process. There's also the concept of library dependencies and dependencies in general. If you have a package, you want to be able to depend on other things. If you have a module, you want to depend on other modules. If you have a C library, you want to depend on other C libraries, and so on. But that comes with dependency accuracy, which are different problems that work together, and oftentimes in package systems, they deviate, simply because they are provided by different mechanisms. Dependency accuracy means that, sure, I have dependencies, but I can name all of the accurate dependencies, or name all of them accurately. For example, if you have a Perl module and it has several dependencies, you want to make sure you have all of them. You don't want to have some of them. But this is something that for a lot of systems is very difficult to do. For example, if you have a Perl module that has a C dependency because it has some C bindings, you cannot specify this on CPAN. There's the alien packages, but they're not there yet, they're not complete, and then they'll provide everything. So there's one example of something you just have a hard time doing, even though we have a very prolific dependency system. Additionally, one of the more interesting perspectives that we have at a large-scale company is the concept of atomic installations, upgrades, downgrades, and reversions. And this is something that most packaging systems don't even think about, but for us it matters. So if we do a deployment, during that deployment we might have upgraded a few packages. We would like to have that installation either work or not work. We don't want to have it halfway through, which means that maybe some things were installed, or it could be a complete disaster where even what we try to install only halfway installed, and then we have a broken state. So this is the concept of atomic. Atomic installation, upgrades, downgrades, where you have an entire transaction that you can perform, and if it fails, all of it fails, and you're fine. And reversion is a different thing than downgrade, because reversion basically says to the previous state. If we do an upgrade of the software, and part of the upgrade of the software actually means downgrading a dependency to a version that has a certain feature that was removed or is implementing it better until the new version fixes it, then a reversion means going back. And going back might mean going back to a newer version of a dependency. You don't know this, and it happens. So that's something to take into account. These are different things, and most packaging systems don't even think about it. Lastly, the concept of multiple instances. This is something that a lot of packaging systems don't provide because they are system packages. And there are a lot of places that do provide it, but only halfway through because they think of users and not of servers. And this becomes a very awkward, muddy water kind of thing. But it actually makes sense. We have a system at work that is written in Perl and that maintains the different Perl packages that are installed. If it installs a package which then breaks it, then it basically cuts off its own legs. And then it cannot remove that package because it itself might use that package, which means it broke itself. So having multiple instances means that that could be run on the same machine, but without being affected by what it changes. So things like that are actually very valuable. Also, upgrading Perl versions is very important to be able to have more than one Perl version available. In most systems, you have to put the version as part of the name, and it becomes a complete nightmare. So I want to cover what these mean in the context of the applications and solutions that we do have. These are CPAN clients. You can think of these as also NPM and also PyPy, and other languages have similar things, and they are all somewhat the same in their abilities. Even though some of them are nicer, some of them are shinier, some of them are faster, but they're all somewhat the same in what they perform and how they perform their work. So when we talk about pre-built packages, none of these can do it. They all take sources, build them, test them, and then install them. If you take a look at stuff like CPM, it just skips a bunch of stuff. If you think of the new static install option, that works, but not for C packages or anything that has a dynamic config to it. And most of us don't. How many people here are familiar with the new static install concept on CPAN? One person. So this is a new idea of like, oh, well, if we don't need to build anything, we can just copy it over. That gives us the behavior of pre-built, but it isn't really pre-built. It just doesn't need building. There's a difference. When it comes to dependencies, I need to note this because where I'm from, we have this marker, but a lot of people don't know it outside. So this is a V with an X, which basically means halfway through. Like it has it, but doesn't fully have it. So when it comes to handling dependencies, all of these can handle dependencies, which is great. If you have a CPAN module, you can depend on other CPAN modules, but you can only depend on whatever language you are in. These are language-specific installers. So a PyPy cannot require a Perl module that is somehow used internally by the application, like it forks and runs Perl and uses a module to do a specific task. That happens in a lot of applications because there's a Perl module that does that. PyPy can't do that. We can also not depend on other PyPy packages in Perl. So we halfway through it. When it comes to accuracy, though, what we do really well, because any language has its own metadata. And using that metadata, we know exactly what's needed. We know exactly which Perl versions, which is unfortunately the only thing we support. We know when we need them, how we need them, what we're going to do with them. It's fantastic. When it comes to Atomic, we don't have that. I could say that we halfway have it, but sort of. So when you want to install something, if you run an install on a package that has about, let's say, 20 requirements and dependencies, it will install them. If the 15th fails, you won't have a broken state, but you will have installed 14 new modules. So you half-weight it, and that's tricky. That's very problematic. And you can't revert. You can't just go, what was the thing before? Let's just use the older version. That doesn't exist. We have multiple instances supported, though. You need local lib, Perl brew, PLN, and stuff like that. Carton has an honorable mention because it tries to fix the pre-built part, but for everything else, it's the same. Let's take a look at RPM and deb. These are the system packages, so any distribution has these. It has pre-built packages because it actually creates binary packages that you can just then copy over and install, unpack. It handles dependencies really well because it's an arbitrary system, so you can depend on anything you want. It basically represents everything in RPM packages or in deb packages or whatever other system packager you have. And when it represents it in that way, you can just depend on any of these. So there's an RPM that represents a Perl, so one RPM can use another RPM. And that RPM could be a Perl package, could be a Python package, could be a C package, could be whatever you want. But when it comes to accuracy, it is bad. It is bad because it is a very reductionist system. It has to represent something very, very complicated in a very reduced form. And that is wrong because it loses all of that information that was available. So it does stuff like grep, and then see how many use statements I can find, and hope they're not comments, or they're not in a context in which they actually don't run, like in documentation. And there's stuff like that. For us, for example, at Booking, for a while we couldn't use Perl Critic because Perl Critic was flagged on a lot of tests, and because it was flagged on a lot of tests, it accidentally thought that everything depends on it, which it wasn't. And because of that, we had a grep-v, which basically inverts that and says anything but Perl Critic. So it was a block list. And we had to fix that. When it comes to Atomic installation, it is correct. It has transactions. So you can have a transaction, and that transaction either succeeds or fails. And if it fails, it just fails, and you're back to what you were before, which is great. But it doesn't have reversions, which means if you have to go back, you need to create a new transaction of everything that existed before, and then perform that. And it doesn't support multiple instances, but mostly out of design, because it's meant to have a system-wide solution. It's meant to maintain an entire distribution, an entire system. But when you come to applications and not just the system itself, this is a problem, because applications need multiple instances. So you can say, we'll just put everything in a Docker. That would work, but that's additional maintenance. There is a class of new packaging systems, such as Brew, which basically gives you a system-provided packaging. It's nice because it's more up-to-date in most cases, but I think it falls short of all of these. First of all, pre-built, some of it could be pre-built, some of it is not pre-built, some of it is compiled on the spot, some of it isn't. Pretty frustrating. But it has the ability to pre-build, but then you have to pre-build for every thing. You have to pre-build for any kind of user, because anyone could use Brew, and that's complications. Dependencies, it handles dependencies because it represents everything as Brew, so it created its own realm. But the accuracy, again, falls short because it has to reduce that into a Brew situation. So that's tricky. When it comes to atomic operations, it also fails that, mainly because it just downloads and tries to install, just like CPAN. So that's also a problem. And when it comes to reversions, can't do that either. And it doesn't have multiple instances either. You can say, well, it's based on users, so you just create another user. But that doesn't really work when you have an entire permission system of a distribution. So 2 additional mentions. Bazel, has anyone heard of Bazel? Okay, thank you, Brad. Bazel is this system that Google came up with, and people are really excited about it, but it is just a build system. So it is equivalent to a makefile. It is not a packaging system. And Bazel, I've been to a talk that Google gave on it, and it seems to be one of the similar, other similar things that Google provides, which is we wrote something that works for something very particular that we do, and if you do exactly this for the situation that no one else has, it will work perfectly. So it's great that they open sourced it, and you could adapt to it, but it isn't a packaging system, so I just want to make a note of that. Because people tend to ask, well, why just not use Bazel? It's not a packaging system. It can't do Perl, for example, because it's not meant to. It's only for C or C++, stuff like that. Active state deserves another mention because active state actually solves many of these problems, but they have to maintain their own thing, and it's also not an entire system, but they do solve a lot of these, so it's worthwhile looking into. This is a matrix of all of the possibilities. You can see that they all pretty much fail at something, and the problematic thing here is that while maybe one or two are not the worst, not having the specific things that they don't have is actually a problem. So if you take a look at CPAN, the one thing it really fails at is pre-built and dependencies. So you could say, okay, it doesn't have atomic, so maybe we can work around that, but it has to have pre-built packages. It has to have good support for dependencies. RPM has those, that's great, but its accuracy is really flawed. And we get into a lot of workarounds. I've seen it in multiple companies, and it is very difficult to crawl out of that. It also doesn't have multiple instances. So now we created packages where it's Perl and the version of Perl, and that's part of the name because we want to have more than one version of Perl installed. That becomes a nightmare to maintain. And if you take a look at Brew, I think it fails the most things because while it could be pre-built, you're depending on someone else doing that, and while it has dependencies, it's not accurate in it, so we kind of lose everything in it. So we came up with Pakket. And Pakket uses two very specific ideas, delegation and generalize, and these seem to be mutually exclusive, but they actually work really well together. Delegation means that you pass on the work to a different part, a different component that is more capable and knowledgeable in how to do the job, and you generalize providing common behavior to components. And I want to explore some of those ideas here. Pakket has 4 stages of operation. 2 of them are actually optional. The first one is generate, which is optional. It helps you create a set of specs, which you can do manually as well. It then builds things. You can then install them. And optionally, you can run them. And when I say optionally, what I mean is that you could use the Pakket runner in order to run things, but you could also ask it to create an environment that you will just use whenever you want in whatever context you want. So it's optional. So let's talk about generation. To generate things, what we actually do is scaffold. And scaffolding basically means we take a look at a system that has metadata, ask it for information, and then generate the equivalent things in Pakket. If we're talking about Perl, we have MetaCPAN. MetaCPAN has an API. It is very extensive, and it gives us all the information we need in order to know which Perl packages depend on which Perl packages, and for what. If you're interested in this, Miki Nasriachi gave a talk about this, and he did that yesterday, so you can't watch it now, but it will be on video, so you could watch it later. These are the commands that we use in order to generate. We call Pakket, we have a manager, we call add, and this will basically look at a system and generate the equivalent. There are 2 packages here. One is native Perl, and another one is Perl Dancer. And these are different. What these have are actually categories, the packages themselves, and a version. And the category here, the one in red, helps the manager know which meta system to go to in order to get that data, which metadata API it has. So when it's a Perl system, just like the lower one, the second line, it will actually go to MetaCPAN and say, I'm just going to ask you. And that's something that reduces all of the need for grepping everything and assuming we got it right. Instead, it just goes to the appropriate metadata system and asks for it, and that's the delegation part. Instead of saying, I know this, Pakket says, I don't know this, and I'm not going to try knowing this. I'm going to ask someone that I think does know this. Yes?
Maybe I'm jumping the gun here, but when Pakket sees that you're putting in Perl Dancer 2, it must have some way to find out that, oh, this depends on native Perl, but only one of the following 7 of 43 possible versions, right?
Right, so the question, if I understand it correctly, is the dependency of a language specific with the language interpreter?
Yeah.
In this case, Pakket will not do this. You can bind them together to say, I would like to package a language specific module, and I would also like it to bind against the language which I will also build. If you don't do this, it will simply use the system Perl that you have running, which is great for us because that allows us to maintain, for now, Perl in RPM form and build everything against that. And then later on, when we want to, we will move Perl to Pakket and build it ourselves as well, and then build against that. Okay. So this is how it might look like. And when I say it might look like, it only because this is one form of having it. In Pakket, this is also abstract. I will talk about this later. One form of having it is a JSON file. And what you can see here is the two different packages and how they would look like. They have the package details, which is the category, name, version, and release, and you have the prereqs. So the category itself is one of the strongest emphases of Pakket. In a lot of packaging systems, you have categories, but the only reason you have categories is because you want to know what kind of world to associate it to. So this is games. So you go there and you can find it. It's discoverability. But for Pakket, it isn't about user discoverability. It's about the application discoverability. It's about the builder. So for Pakket, it says, oh, this is a Perl package. I know how to not just get data on it, I also know how to build it. And this is another form of delegation. Pakket will not try to run arbitrary commands. Instead, it says, oh, this thing is Perl. We have a tool chain that a large group of people have put a lot of effort in. I will just call that instead. And this is something that is very distinct to Pakket when you look at other systems. Instead of other systems running arbitrary command, Pakket says, you know what? The hell with it. I don't know this. I'm just going to ask someone who does. And that's very, very important for us. And that's how we can support multiple languages very easily. We just use their builders. It has a name. The name could be anything. But it should probably reflect what it is upstream because it helps you make more sense of it. Same goes with the version. Pakket doesn't actually care what the version is. You could put any version. And Pakket even delegates understanding versions. One of the things that we had a problem with in RPM was that two releases of file spec, which is under the path utils distribution, had different versions. And those versions were Perl versions. That made total sense when you did the version comparison in Perl. But when RPM wanted to upgrade, it didn't understand it because Perl has weird versioning schemes. And Perl knows how to handle this, but other systems don't do this accurately because it's not exactly decimal. So we wanted to do an upgrade, and RPM said, nope, this is not a newer version. And you had to say, well, no, see, 1.8 actually means 1.008, which is actually, no, but see, if 1.700, that's actually higher than 1.8 because 1.8 is 1.00. And you can't tell RPM that. Like, it doesn't understand it. It has a versioning scheme. But for Pakket, it basically says, you know, the category that we have here, I'm just going to ask it how it resolves versions, which means that you could support any version you want. Have you ever seen Git versions? They are not simple. There is a module on CPAN for comparing Git versions because it is that complicated. But for Pakket, it just says the version could be anything. I'm just going to ask the category. It will know, although it does have defaults. And you have a release, and the release is meant to help you maintain your own subversion. So maybe you patched it. Maybe you took version 0.205 of Dancer, and you want to patch it with something. You want to add a callback somewhere, and maybe you've even submitted it upstream, and we accepted it, but you don't have time to upgrade it, or we didn't release it yet, doesn't matter. What happens is that you can maintain your own releases on top of it. So it's very important. And then you could use the version to reflect the upstream version. So you could always remain in check. Any question?
Yeah, so suppose Pakket needs to, it has two Perl versions and it needs to compare them and decide which one is later. How exactly does it do that?
It uses Perl in order to compare those.
Right, but what does it use?
So I didn't put that in, but I will answer that. Pakket. Well, it's more note to myself. I should have maybe put it in. But Pakket actually comes self-contained. It has its own builder to create its own instance with its own distribution, and you can provide it as an RPM self-contained, or you can install it directly, or you can scaffold it yourself. But basically, it creates its own instance of Perl with its own local lib in order to run itself completely separate from your environment. Pakket is actually written in modern Perl, and it builds its own version of Perl for itself. So you can put it on any system that doesn't even have Perl. It doesn't use our system Perl until it needs to build if you didn't provide a specific Perl you want to use in order to build. Yes?
Is the release number only used by the category or also by package itself?
The release number is part of the package. It isn't used by all of the metadata systems because it's meant as a detail for you to distinguish other releases of maybe the same version. Well, for the release, we're trying to just keep it a simple int. At the moment, we're keeping it a single int. If we find a reason to change that, we will. But the idea is that the version could be arbitrary, and the release will just give you an incrementing number to distinguish between them. And the prereqs, I haven't gone into it, so maybe I should. Prereqs, which is our way of saying requirements, is simple. We took that idea from Perl. Does anyone here know Node.js, NPM, and stuff like that? Because we were playing with that a little bit for Pakket just to see how far we could stretch it. And they don't have a very strong dependency detail. They don't have a lot of details for the dependency systems. So they basically have requirements and dev requirements, and that's it. And they're not even together. It's kind of weird. But for Perl, we actually have, is it runtime? Is it this? Is it that? Is it recommended? Is it optional? So we took some of those ideas, and our prereqs for us maintain the category. They maintain the phase itself, like at which point do we need this? Do we need this just to build it and then we don't need it later? Do we need it just to run the test and then we don't need it later? Do we need it for runtime? So you can maintain all of these, and then you say the name of the package and the version. So we could see that, for example, whatever this package was, in our case it was the answer. I'm not showing all the dependencies. The answer has more than those dependencies. For the configure, we definitely need the x-util makemaker category, package, and a specific version. This is similar to Perl in the sense that this is a minimum version. But you could also indicate a specific version because it actually takes the spec of Perl to say equal, greater, less than, and stuff like that. We also added that. And you have a test category, a test phase to use the Perl test simple. And the important thing to remember here, these are not Perl packages. These are other Pakket packages that reflect Perl distributions. Okay, so which kind of phases do we have? Currently, we use the configure for build time, test, and runtime. How do you build things? This is how you build stuff. You basically run Pakket, you say build, and then you say, I want a specific full package. It is Perl YAML 1.70. I think at this moment you also have to provide the release, and if you don't, it gives you the latest version. And if you don't give a version, I think this fails because it wants you to be more explicit on what you build. When you scaffold, in our example, we just said Perl dancer. So we went to cpan and said, what's your latest version? I'll just use that. It's a shorthand. Installation is just as simple. You just ask it to install something. And you can ask it to install anywhere because Pakket creates its own complete self-contained library directory that you could just install stuff into. And it will install C stuff, Perl stuff, and it will bind all of them against each other correctly, and you could just run stuff from there. So you can install to multiple locations. When you want to run, it's also simple. Call Pakket, run, and you ask it what you want, where you want to run things from. This is one way in which you just output a bunch of environment variables, and then you could use those environment variables wherever you want. This is similar to how ProBrew works, or how locallib works, which it binds to whatever environment you have in order to automatically load things from that. This is what we use in order to run stuff in a micro-WSGI server. So we basically use this to say, I want to know what the variables are in order to run stuff from this directory in which I've installed a bunch of stuff. And we installed libraries in there, and Perl stuff, and C stuff. And then in outputs, all of those, we take them, we put them in the init script of micro-WSGI, and then there we go. Micro-WSGI now uses our system Perl, but loads all of its dependencies, including a few C dependencies, from a different location. A different way to run is to provide a specific thing you want to run. This is an example of also running a simple command. We're going to Pakket. In Pakket, currently it installs libraries, and the libraries have something called active. And the reason it does that is because Pakket maintains multiple instances as well. It automatically cleans, and you can control how many previous versions you want to have, but it actually maintains multiple versions, and it has a symlink to the correct one, which is active. That means that with Pakket, you can revert with one command of changing the symlink to the previous versions. And when you run over 1,000 servers for one deployment process, over 10 times a day, this is actually not bad, because then the reversion is instantaneously, and it's also atomic. It either worked or it didn't, and that's it. So this is actually much faster than other systems, because it's one symlink. That's a very low cost. We have a concept called repositories. This is an example of both generalizing and delegating. The concept of repository is one of the things I'm actually very proud of with Pakket, and I hope to take that into other realms. The repositories in Pakket are meant to store information. There are 3 bits of information that we want. First one is the sources. The sources are the actual stuff that we want to build. It would be a Perl module, it would be a C library, it would be a C++ library, or whatever it is. Then you have the spec, and the spec describes what you have, which we've seen those. Lastly, once we build them, we have parcels. It's one of the places where we were able to maintain the concept of packaging. So you have a package, and the package is actually a parcel. Kind of funny. Okay. So the sources, specs are formed together in order to create a parcel, and then you deliver those parcels. Now, the trick is that some of this is content, like a spec is just content, you know, it's a blob. It's probably a hash ref, and the sources and parcels are actual files. But we decided to create a concept known as repository to store both. The idea is that any repository that we have uses a repository backend. The repository backend implements how to actually store information, and each one supports both storing content and storing files. If it is a backend that can only store files, it will generate a file from that underneath the hood and under the hood. And if it's only meant for content, it will actually generate content from that under the hood. And you shouldn't know this. So when Pakket says, I just want to store this parcel, and I want to store it here, it will find a way to store it there. And you can store it there, everything else as well. I'll give you an example of a backend that we have. A file backend is one of the most comfortable ones for system administrator just because we know this very well. So we will create a file of the parcel, like we have RPM file, we have a file of the spec, we have a file of everything. So Pakket can do this as well, and it will store everything within a file. If there's a blob, it will actually generate a file from that. And it maintains IDs for everything, so there is no collision. Another way to do this is a database. So if you want to share some of this information, let's say specs, you want to put specs in a database so everyone can edit specs easily even if they don't have access to that machine. You want to create a web API. So you can do that. That's very useful. But you could also store the files in a database as well, which is pretty cool. And it maintains an internal index for SQL-based stuff. It uses DBI, so it basically supports any DBI-supported database, and it maintains an additional index to make some things even faster. Lastly, we have an HTTP that we've implemented as a remote storage. And the reason we've done this is because you basically build stuff and then send them somewhere so they could be installed by everything. So we created an HTTP storage backend, which basically means I would like to store these remotely. This has a complementary application with Pakket called the Pakket server, and you can run it by just calling Pakket serve. It will run an instance on the spot. It's written with Plaque and Dancer too. And what it does is serve an HTTP API, which you could use to receive whatever it is and store it. So this is what you run as your mirror when you want to upload as an HTTP repository backend. You want to upload a parcel or a configuration. Now, the nice thing is that this is all just configured. So you don't have to know any of these details except saying, I have a Pakket instance here to build stuff, and I have a backend for my parcels, and it's over here, and I have a backend for my specs, and it's over there. And that's it. And you just have to say, this is HTTP, here's the IP, this is a database, here's the DSN. The nice thing about this is because the server itself also has a configuration for how it eventually stores stuff, it could also use either a database or a file or another HTTP endpoint, which now is when things become very interesting from an architectural point of view. So usually what you would do is you would have a mirror, you upload to the mirror, and it stores it on disk. And then you have like an NFS share and you store everything there. But what if you have another one? Because we've exhausted the bandwidth when we do deployments. We literally exhaust our bandwidth. So we have to now create this chain and this multi-level architecture for RPM mirrors, YUM mirrors. With this, you could easily do this because you basically say, well, this is an HTTP, and then on the HTTP, when you have this server, in its configuration, you say, well, you're storing some of those over here. It also supports multiple endpoints, and it's arbitrary. So you could say, I have an endpoint for all of my packages that relate to a certain type of Perl, and everything is built against that Perl, and I'm going to store it on this endpoint that will go eventually to this HTTP mirror over there. And this one will be stored over here, and this will be stored over there, and you can really go nuts with this, and it's a lot of fun. And it takes a long time to explain because basically everything is allowed, so you can literally go anywhere you want. It's pretty cool. So we're kind of reaching the end of the talk, I think. I want to share just the status of Pakket at the moment. First, everything that I've discussed works. So basically the system works. You can scaffold, you can build, you can install, you can run. We have built a one server role that requires 12 to 1,300 packages, just Perl dependencies. And it has also a few C dependencies, and those also have a few C dependencies. Some of them we said, we have it in RPM, that's fine. Let the system administrators take care of that. Some of them we said, actually, those have some security fixes that Red Hat didn't have or our packaging system didn't have. Let's just add them to Pakket, and we build them with Pakket. And some of them are built against others that are in RPM form. So it's very versatile. And it takes our current setup at work for building the appropriate RPMs for it can take about 30 minutes. They can take even more in some packages. But with Pakket, we've built all of them, about 1,300 in 30 minutes. 20, was it? 20 to 30 minutes. So that's not bad. The time we take some of our sysadmins to build one, we've built 1,300. Pretty good. We have support for native packages. Native packaging refers to specifically anything that it compiles to true native, and that means C, C++, stuff like that. We do this by supporting makefiles, but only makefiles at the moment. We also support Perl packages, and that doesn't matter if you have makefile PL, if you have build PL, if it's actually under the hood using module build or module build tiny or make exutil, make maker, or make install, module install, or all of those things. They're all supported because we just delegate to the Perl chain. Like, hey, you know how to do this, just you do it, which is great. And oh, I'm sorry, we also support Node. This was kind of like an experiment to stretch it, and we were easily able to add Node.js as an interpreter and then a bunch of Node packages to connect against it. I should give at some point an entire different rant on how the Node.js packaging system seems to me unripe and immature yet in its design. I think that there are a lot of ideas that we know in Perl simply because we've suffered for a very long time brewing over these, and we've got it to the point that we will never claim it's perfect, but it is far more capable than a system that we would design from scratch. And we also learned a lot from C dependencies and other libraries that we've managed as people beforehand. An example is that Node.js packages don't have phases. This is very unfortunate. For us, we have multiple phases, and they even have a level of association. So it's not just really recommended, it's also suggested. Like there's an option suggest in Perl. So that's pretty cool, but Node.js doesn't have a lot of that. For us, the different phases of build are actually split, so you could do them manually separately, which we heavily use in Pakket to be able to say, hey, we want you to now build this, and now we want you to install this, but we want you to install this here. And in NPM, it's very geared towards users on their desktops, which is difficult because then it tries to bundle one in the other, and we had a hard time untangling this. So that would be a completely different rant. But it wasn't that long, and now it wasn't that long to do. It wasn't too difficult, and we were able to fully manage a Node.js instance, including the interpreter, which is kind of cool. We're not doing anything with it, but it's there. So we have support for Makefile, I've mentioned, and we have command line utilities to do everything, which is pretty cool. And I'm very happy about this. And it is free and open source. It is currently under my repo, which is only temporary. It will be moved to the booking.com repo on GitHub. And it will be released to CPAN, just not yet. We have to do quite a few trimmings and rounding off sharp edges before we do this. So talking about sharp edges, there are quite a few sharp edges, mostly because we are not a large group of developers on it. We're basically 2 people. We've grown to 3 people at some point. We've gone back to 2 people, and then we've grown to 3 people, and one of them is me, and one of them is Mickey, and we have additional responsibilities with the company in and outside, so it is taking our time, and we're taking additional projects, so kind of tricky. So let's talk about sharp edges for a little bit, kind of like a full disclosure thing. First of all, documentation. It is either old or outdated or just does not exist. This is difficult. The documentation changed quite a bit because we've changed the program quite a bit over time. Also, tests become outdated very quickly, and they require scaffolding and a lot of pre-built data in order to test it. So you can't just write a test for a build. You actually have to build something and then test the entire thing. So this is not easy either. So the tests have become outdated, and we have to really work on them more. We want to support additional builders. So when we say native, we basically mean makefile, but we also want to detect scones or CMake and stuff like that, and also run them. So that's very important as well. We don't have that yet. It shouldn't be difficult, but we don't yet have them. Some of the ideas that we want are meta categories. So you could create your own categories. So yeah, there's Perl and there's Node.js and there's native, but you could create another category called, for example, booking, in which we build booking applications. We can have another category, which is static, in which you just copy files over because there is no build system. You could create a meta category of a bag, which was an idea that we had that basically allows you to create one package of a bunch of other packages built. So you could deploy an entire thing in one shot. So that's another idea. We have a ticket for it, but we didn't build it yet. We got to clean up all of the metadata parts. This was not a simple process. We've discovered a lot of distribution errors, a lot of packaging problems and bugs in modules on CPAN, and this is not easy to fix. In Pakket, you can just patch it, that's fine, and just make a new release out of it. But we also had to work around a lot of it in our generator. And there are, I think, 1 or 2 meta CPAN bugs or CPAN issues that we have to clear out as well. And luckily, Miki Nasrati, who works on this program, is also a core developer in meta CPAN. And we get to work with CPAN directly as our main metadata system. So we're able to adjust it and add things as appropriate that we find. But that we really want to kind of yank it out and put it back together again. We want to add concept of tags. So we want to be able to say, well, here's the arbitrary piece of data on this particular package. So for example, this particular package is also tagged as fast or thin or secure and stuff like that. Just kind of be able to manage those in this way. And we want to normalize all the tooling and the command line options because right now they are abundant. We've reached 4 levels down of subcommands, something that app command is not happy with. So this is tricky. When you want to list dependencies, it's package, manage, list, deps on a package. It's not that easy, and we kind of want to normalize this across the board. If you want to play with it, if you want to look at it and complain, or just look at it, you can find it right now on my personal repo, but it will be moved to the booking.com repo. We just kind of played within that repo and kept it there, but we should move it. If you're interested in working on it, patch is welcome. We'd be really happy to discuss it. We'd be really happy to accommodate things that you have. And if you're interested in helping with it, we would really enjoy it. Now, if you, on the other hand, would like to get paid to work on it, we are hiring. So if you're interested in working on this as your job and get paid for it, just in case the company you're currently working in will not pay you to do this, we will. So if you're interested in working on booking, either on this project or other open source projects, or some internal code of course, come see either me or Mickey or Graham over there, and we all work at the company, and we'd be happy to give you more details. That is the end of my talk, and I will pause here for any questions. Thank you. Yes, Brad.
So, how would you handle like different distributions in operating system distributions? Because that's one of the problems that we have to deal with. We're going to support like CentOS 6, and we want to test CentOS 7 or FreeBSD, for instance, as a possible replacement. Is that a concept?
That's an excellent question. So how do you handle different distributions? And some of it is different distribution versions like CentOS 5, 6, 7. Recently, someone told us that CentOS 5 is very common in Japan, for example. and you might have 6, you might have 7, and you might have FreeBSD or OpenBSD. They are completely different operating systems. So there are two elements to this. One is supporting multiple operating systems, and the other one is supporting different versions of this operating system. What we have at work is a set of mock environments. They're basically the Red Hat mock thing. I don't know if you're familiar with that. You can also have Docker for the same concept. Those contain Pakket instances that are used to build stuff on those architectures and on those operating systems. And they will pass it on when they build it. Their parcel repository is set up to go to our main repository under a path that correlates with that operating system and version. The mirror itself that is using the Pakket server maintains multiple endpoints that are stored in different places and could be then passed on to different machines as well if you want to split up the hosting itself. So your FreeBSD image, Docker, machine, or mock environment could just build to the server and throwing it into /FreeBSD version or /version, whatever endpoint you want, it's arbitrary. And on the server, it will have that endpoint configured, and all of underneath that will be stored in another repository. That could be a database on disk, a database it has access to. It could be a file on disk. That could also be another HTTP or something like that if you want to split it per servers. So that's how we maintain that. And we have to maintain, at the moment, we're building for CentOS 6 and 7 for Perl 5, 18.2, and 24.0.
Just as a follow-up.
Yes.
Is that one command that you would issue then? So like when you log on to a build server and say build this package, and then it would build across all of those different
No. No, Pakket doesn't have a meta build system in a sense where it can manage multiple Pakket instances. We just have a very simple script that just does a for on a for those options and says, for each CentOS, for each version that we have defined, here's the machine, and it literally just runs. In mock, it's just mock run, but in Docker, it would be Docker run or something like that, and then Pakket build. And that's it. And that it builds them and then sends it off to the appropriate repository under the appropriate path. And that's it. It could also send it off to a common database or an NFS share that it has access to. But HTTP works really well for us because we can put the machines in completely different places without worrying about database permissions and stuff like that. It uses an HTTP endpoint, and that's it. So, does anyone? Yes, sir.
You're building CPAN modules. So do you actually execute it on your build machine, get all the libraries, any files associated, and then package that to be distributed to your other machines?
Yes, sir. What we do is basically, once you've scaffolded, either you wrote your own configuration manually or you scaffolded and created a configuration, and you have the sources as well fetched. What it will do is take the source. Right now, we will take the source from a source repository. We would like to introduce a repository type that is like CPAN. So we would take the source from CPAN, or GitHub. We will take the source from there. But the trickiness with this is that, well, CPAN is more plausible, GitHub is less, because you put the original raw source there. Oftentimes, you would then build from that something if you're using Diesel, and often from that, you will actually build again. So there are multiple layers. A bit tricky, but at the moment it will just be a source repository. The generator downloads and puts it in there for you. And what it will do is take the configuration, build it on the machine, on the build machine that you have, and then store the parcel somewhere. That storage could be local, but it could also be remote. You define it yourself.
So you build it once, and then you can deploy it multiple.
Exactly. So we built it, and once it's built, it is a parcel. And it is in a parcel repository, and then when you want to install, you basically say, I just want to install. It has configured its parcel, or you can say, I want to install from there, and it just pulls it in and unpacks it. And that's it. The installation part of Pakket, other than fetching the package, is basically untar something. But it untars it in an atomic way. So let's say you want to install a package that requires 3 more packages, that one of which requires 5 more packages. Now you get like this nice chain. It will start unpacking all of them into a directory. That directory will not be live. If it finishes everything successfully, it will turn that on. And now it is it. And if you want to revert, it will just go back one. So it is entirely built into an atomic style. So we could either deploy it successfully, all of it, or not at all. Or we could revert it instantly, or not. we're done. I'd like to thank you very much for your time, for your interest, and if you're interested in that, come see me, take a look at the GitHub project, show us everything that we can fix on it, help us out, or come see us later if you're interested in working on it or ask additional questions. Thank you very much. Have a great Tipsy.